A question that I'm hearing more often goes something like this. Why are we now seeing computer storage amounts specified in units like MIB, GIB, and TIB instead of MB, GB, and TB? Here's an example of the confusion. I created a file named 10millionbytes.txt, which contains exactly 10 million bytes of data. When I look at the properties of this file with a Windows operating system, it shows that the file size is 9.53 MB. When I look at the same file's info with a Mac OS, it shows that the file size is 10 MB. And when I look at the same file stats with a Linux operating system, it shows that the file size is 9.6 M. You will not only see size and unit differences among different operating systems, you will also see them within the same OS, and sometimes even within the same app. When I look at the 10 million byte file using Cloudera's Hue interface, it shows that the file size is 9.5 MB. But when I look at the same file using Cloudera's Navigator interface, it shows that the file size is 9.54 MIB. Here's a summary of the 5 different sizes that we saw. So are any of them correct? The Apple operating system and the Cloudera Navigator app are both correct. To clear up the confusion, let's take a look at the official definitions. First, we will look at the metric units, which are defined using the base 10 number system. Kilobyte comes from the Greek prefix kilo, which literally means thousand. The metric unit symbol for kilobyte is KB. The number of bytes in a kilobyte is 10 to the third power, which is 1,000 bytes. Now, we are used to dealing with powers of 10 in the metric system. For example, the number of millimeters in a meter is 10 to the third power, or 1,000 millimeters. A megabyte contains 1 million bytes. Therefore, when the Mac OS showed that a 10 million byte file contained 10 MB, it was correct. A gigabyte contains 1 billion bytes. A terabyte contains 1 trillion bytes, and a petabyte contains 1 quadrillion bytes. The problem with using base 10 units for computer-related numbers is that computers operate using the binary base 2 number system. However, decades ago, computer professionals noticed that 2 to the 10th power, which is 1024, was nearly equal to 1000. So they started using the metric prefix kilo to mean 1024. However, this logic broke down as storage capacities grew into millions and billions of bytes. So around the year 2000, the International Electrical Technical Commission defined new standards for data storage. The Kilobyte was a new unit, abbreviated KIB, and defined in base 2 as 2 to the 10th power, which is 1024 bytes. The name of each new prefix is derived from the name of the corresponding metric prefix by retaining its first 2 letters and changing the third and fourth letter to BI, which is short for binary. The Commission stated that in English, the second syllable should be pronounced as BEE or B. Therefore, kilobyte is related to kibibyte. The symbol of each new prefix is derived from the symbol of the corresponding decimal prefix by inserting the letter I, which again recalls the word binary, and always capitalizing the first letter. The number of bytes in a mebibyte is 2 to the 20th power, or 1,048,576. So, for a 10 million byte file, we divide 10 million by 1,048,576, and the answer, rounded up, is 9.54 MIB, which is exactly the size that the Cloudera Navigator app gave. Gibibyte, TeddyByte, and PebiByte are also defined with base 2 numbers. You can see why decades ago kilobyte was used as a close approximation for 2 to the 10th power, because 1024 is only 2.4% larger than 1000. But as storage sizes increased, it no longer made sense to use metric units because the gap between reality and the approximation grew significantly. Here's an example from another Cloudera app named Cloudera Manager, which shows that 76.7 TeddyBytes out of 289.2 TeddyBytes have been used. Let's see how the numeric value changes when TeddyBytes is converted to terabytes. 289.2 TeddyBytes is nearly 318 trillion bytes, which rounds to 318 terabytes. The difference between 289.2 and 318 is fairly significant. Well, that's the end of this video, so I hope that you have a better understanding of the newer binary units now.